This is my first video on calculus on the channel, and it's starting with Calc 2C because I'm currently in Calc 2C, and I'm going to be explaining the first part before the first midterm in Calc 2C, which is basically about series and testing. Usually for series, it's testing for conversions, sums, and eventually power series. So first, to start with series, testing for convergence, I'm going to do a couple videos about the different tests, most of the different tests you can do to test for convergence and to try to find the sum. But we're starting with the first test, the most basic test of all, which a lot of people gloss over because it's seen as not important, but it could save you a whole lot of time if you just do this test. And this test involves taking the limit of the sum. And usually you can do this test kind of in your head. If you've been doing series a lot, you can just look at the function and tell if it passes or doesn't pass this test. But let's get right into it. So the end term test is basically testing the limit of a of n, which is the function the series given as n goes to infinity. And the point of doing this test is to determine whether the series either diverges or inconclusive. So the result, this test can only tell you if the series diverges or if you have to analyze further and go in depth, which is the inconclusive part. And to put it short and simple, the end term test is just taking the limit of the function as n goes to infinity, and if it gives you 0, that means it's inconclusive and you have to do further tests. Or if it doesn't give you 0, that means it diverges, and you can just end there and say the series doesn't diverge. The series doesn't converge, so it diverges, and it diverges to whatever the limit says that it does. And the idea behind this test is that if a series converges, that means that as you take the limit, as the n increases, it should go to 0 eventually for it to converge. This is kind of unrelated, but if you look at, so let's say this is the series has to be approaching 0 at some point. I'm not saying this is how series look, but if you apply the concept of series to functions, this is how you want the series to look if you want it to converge, which because at some point you want there to be a point where it goes to 0, and then this converges. It's a finite amount of area. Rather, instead, if the function instead is going up, it's never gonna converge because there's always gonna be more. It's gonna keep adding more and more and more, so it's not gonna be able to converge to a certain thing. And that's the idea behind this test, is that you want the series to be approaching 0. So at some point it converges if it's approaching 0. And now for some application, I'm just gonna do a random series, just any series at all, and do the test and see if it converges or diverges. So the first series that I'm gonna do is just, let's say, n plus 1 over n. If this is the series, so you write it in this notation. This here is a of n. So if you're given this on a test and ask something like, does this converge or diverge? In order to find out, you just do the end term test first before you do further tests. So you do the limit as n approaches infinity of a of n, and a of n is n plus 1 over n. And to do this is an easy limit to do. Over n, you just divide every number by n, and then the n over n becomes 1, n over n also becomes 1. So it's 1 plus 1 over n over 1. And if you know limit rules, this goes to 0 since the n is in the denominator and it's getting bigger and bigger as n goes to infinity, so it converges to 0, and you're just left with 1. And as you can see, the result of this test is not equal to 0. So right away, you can just give your answer after doing this end-term test that proves it, that this series diverges. And there, you don't have to do any test to show that it diverges, because you can do this first and foremost, this easy test to show that it diverges. And now I'm going to try to do another function, and this time I'm going to do a scenario where it converges to, not converges, the limit goes to 0. So let's say for this function, series, I keep calling them functions because I've been doing functions all my life, n plus 1 over n. So right here, you're given the series. The first thing to do is always the limit comparison test. And you do it of a of n. This is a of n, given series, ln of n plus 1 over n. And for this series, to do the limit, you can just ignore this ln for now and do the limit of the inside. What is the limit as n goes to infinity of this inside? And we already did it up here. It goes to 1, and then you bring it back, and the ln becomes relevant again. So now it's the ln of this series goes to 1 as it approaches infinity, and then what's ln of 1? It's 0, and that's the answer for as the limit approaches infinity. Ln of 1 is 0. So as you can see, that we did the end-term test, and it gives us 0. So right here, we can't come to a conclusion after this test because it is 0. So we can't say diverges, and we certainly can't say converges because it doesn't give us the whole information. So this is inconclusive, and you have to do further tests to figure if it converges or not. And if you just did this, you might be thinking, this might have been a waste of time. But I don't see it that way, as in, let's say you do it out of every 5 questions, one of it gives you diverges. Oh, you saved yourself a lot of time. You can easily tell it diverges. And eventually, if you get better, you can start doing this end-term test in your head. And from looking at this, you can tell this diverges. This goes to 1. So straight away, you can tell this series is not going to diverge. It's not going to converge if you just look at it doing the end-term test in your head. Which is why I think it's always worth it. You may not have to write it down to save time, but if you can do the series, the limit of the series in your head, I think that it's worth doing to save time.